working backwards mean? I would call it you need to do some algebra and solve for x. Okay. Another way of right. So you can call this solve for x. So whenever I talk about working backwards, we're solving for x. Okay. Sometimes you will be given one of the 5 formulas that I call psyched, right? And you will have to determine, you'll be asked to determine the number of sides. Start with the appropriate formula, then isolate for n, okay? Isolate for n means solve for n. In this case, you will solve for the number of sides. So they give you the angle. You have to figure out how many sides that polygon would have to meet that criteria. So let's start with an easy one here. I tell you that the sum of interior angles of a polygon is 3060. Determine the number of sides. So in a sense, if you look at the 5 formulas, they're giving you that the sum of all angles of this particular polygon is 3060. Right? We know that. So we're going to start with the formula for S, which is n minus 2 times 180 degrees. And then we substitute in. We know that we already know what S is supposed to be, so we're going to substitute that into our equation. So we end up with, I'm going to use a color here, 3060 is equal to n minus 2 times 180. Okay, it's because we know what S is, so our goal is now to find out what n is. And I will suggest you can do this in a number of ways. You can either choose to go 180 and multiply that out, FOIL that out, distribute it. But I'm going to argue that it's going to create more work for you if you do that. Since there is a number multiplying this bracket, and there's only a number on the other side, I will divide both sides by 180. And why am I going to do that? Because it effectively cancels out the 180 on the right side. And so you end up with just n minus 2, and then on the left side you'll just divide, right? 3060 divided by 180, that's 17. Okay, this is 17. And let's continue over here. I'll write that down one more time. And here we can bring the 2 over to the other side. Okay, so it's 17 plus 2 is equal to n. N is equal to 19. I know we're not used to having the variable on the right side, but it is quite all right to say that, because you can, 19 is equal to n or n is equal to 19. It's the same thing. So this polygon has 19 sides. Okay. Okay. 19 sides. Page 36. So that's how you do a backwards question. Okay, so I would say just start with the formula, substitute in on the left-hand side, and solve for n. Okay. So that polygon has 19 sides. We don't have a name for it. So let's do another one here. B. A regular polygon has exterior angles of 11.25 degrees. Calculate the number of sides algebraically. You can't just guess on these ones, okay? You can't just tell me, you know, I can see some of you trying things until it works out, and then you just tell me. You have to actually show me the work to get full marks. So exterior angle is 11.25 degrees. So essentially asking, what is n, right? So we start with a formula. This one is the easiest one of all, in my opinion. So we substitute in the 11.25 here. What does this look like? Cross, multiply, and divide, right? Remember that from previous unit? So if you don't see it, just put a 1 under a number. It's a fraction. It's still the same number, so we have to cross multiply and then divide to find n. So there's nothing to take over or to bring over. You just cross multiply and divide here. So it's 360 times 1 divided by 11.25. Let me just bring this up a bit. And so if you continue, you can just say n is equal to, let's go 360 divided by 11.25. That's 32 sides. By the way, what would the interior angle be? This is just an aside. If I asked you for the interior angle, how could we find out what the interior angle is of this polygon? There's two formulas. Do you remember them? Interior angle is 180 minus the exterior angle, right? That's one way to find out. Or what's the other one? Interior angle is n minus 2 times 180 divided by n. Which one is easier? I'd say this one is easier, right? $168.75. Okay. This is an aside, right? This is not what the question was asking for, but I always want you to keep that in mind, that the exterior and the interior always add up to 180. So if you have the exterior, subtract it from 180 to get the interior. If you have the interior, subtract it from 180 to get the exterior. Okay? And this is a regular polygon. What does regular mean again? What makes a polygon a regular polygon? All sides are equal, and what else? All angles are equal. Okay? So that's something important. So for this particular polygon, it has 32 sides, and every single angle is the same. Every single side length is the same. Okay? Let's do one more, see if you catch the pattern here. You got to be creative, guys. Sometimes you just have to be creative. A regular polygon has interior angles of 171 degrees. Calculate the number of sides algebraically. So they tell you that the interior angle, and that's every single one of them, is 171 degrees. What is the formula for interior angle? We just did that, right? It's this. That one is a very how should we say it? There's a lot of stuff going on there, right? To solve for n on this one, it's going to be a lot of work. But if we have the interior angle, what is the exterior angle? 180 minus 171. Exterior angle is 9 degrees. What's the formula for exterior angle? Super simple, right? So Mr. Dirksen, can I solve for n using this formula? Yes. Can I solve for n using this formula? Yes. Which one is easier? In my opinion, this one is way easier. You just have to understand that if I give you an interior angle, you can immediately find the exterior angle just like that. You just have to subtract it from 180. And vice versa, right? If you have the exterior, you can find the interior. They're connected. So let's solve this one. We know that E is 9. That's 360 over n. Put a little 1 here. Cross multiply and divide. N is 360 divided by 9, which is 40, right? 40 sides. But for some reason, some students are just like, nope, I'm going to do it this way because I want the challenge, right? So I'm going to show you how to do it this way, just because it's good. It's still a good skill to have. So I'm going to introduce 171 here. And I'm going to do this. And I'm going to show you with a red pen what I'm doing. When there's a division, when you have a fraction and the variable is at the bottom, that's the first thing you want to tackle. And the way we do it is we multiply everything by n, right? The whole thing. So you multiply this side by n, and you multiply this side by n. And you can cancel out the n's on the right side, leaving you with 171n is equal to n minus 2 times 180. And here I'm not going to divide by 180 like I did on the very first example, because this number on this side has an n attached to it. So in this case, it's actually easier to just distribute like this. So it's 171n. This is 180n. And negative 2 times 180 is negative 360. Now I'm going to combine like terms, like I already did as much as I could on the right side. So I'm going to take this n, and I'm going to bring it over to the other side. So it's 171n minus 180n is equal to negative 360. (171n minus 180n is negative 9n is equal to negative 360. And I think you'll see what's going to happen here, right? We'll divide both sides by negative 9. So n is equal to negative 360 divided by negative 9 is 40 positive. So it's a lot more work, but you still get the same answer regardless of how you do it. You just have to be very careful when you do. The pattern is going to be the same. Once you insert the number on the left side, whatever we do on the right side basically stays the same. It's the same pattern every time. Okay? I'm going to ask you to work a little bit on page 37. There's one that we just did, and then so try 2 and 3 as well. I want to talk about the third question on page 37 here for a moment. You're supposed to solve for x, right? If this had been a triangle, what would we have done? If this had, like, if you had 3 angles, let's do this for a second. If this had been a triangle, what would we do? This plus this is equal to 180. What should these angles equal to? 360? That would be a 4-sided. What formula out of psych can tell us the sum of interior angles? S. Right? S. You got to figure out the sum first, so you count. Count the number of sides. So it's step number 1. is determine S, right? S is equal to n minus 2 times 180. That one works for every single polygon. And then you'll add these all up and make them equal to that number that you're going to calculate. And then solve for x. Give it a try. Start with 1, and then 2, and then 3. Read carefully. If you can make corrections or just follow along if you feel like you got it. This one here I'm not going to do. I'm just going to show you the answer key. Regardless of which method you used, whether you determined the exterior angle, right, and then just solve for n, regardless you get 75, okay, regardless of which method you used. I'm going to skip that. Maybe I'll just talk about it. Yeah, I'll just talk about it. I'll use my key just to save us a bit of time. This is that second question. We know that it's a pentagon, so we know n is equal to 5. There's 5 interior angles, 5 exterior angles, 5 central angles, right? We know that. To find that fifth missing interior angle, we solve for the sum of all 5 angles, which is 540. Then I go 540 and I subtract the 4 interior angles I already have. So the last fifth remaining interior angle is 134. Okay, that's supposed to be the answer. So maybe if you didn't do this, at least write down the answer next to A, right? For B, make sure you pay attention to this one. It wants the value of each exterior angle. So, by the way, let's cut to the chase. Is that a regular polygon that we're talking about here? All interior angles are different, right? Not like it doesn't even matter, even if all of them are the same and one isn't, it no longer is a regular polygon. So what that means is, what I did is I kind of made a little table here. I listed all 5 of my interior angles. I have 4 here and I found the 5th here. And I just state the exterior angle at every single corner of this polygon. And I just make sure that they add up to 180 at every corner, okay? So this is what the question was asking for in B. And C, is it regular? It's irregular because not all angles, not all interior angles are the same, okay? I'm just throwing out like a little side note. Do you remember what the sum of all exterior angles is supposed to be? The sum of all exterior angle? It's always 360 degrees. That's a good property to have on your study sheet. So if you were to add up these here, you should always get 360, your exterior angles. No matter if it's regular, irregular, it doesn't matter. It's always 360. So that's also a cool property. Okay. Let's get to the last one here. I noticed that it has 6 sides, right? I count the number of sides. So the sum of interior angles is 720. I know that all of them are supposed to add up. It's kind of like if you see a triangle, you know it adds up to 180. If you see a hexagon, it doesn't matter what it looks like, you know it's supposed to be 720. But if you don't know that, calculate it using the formula. Okay? And then watch what I do. I make the sum of all of these angles equal to 720. I go 720 is equal to every single angle. There are 6 angles that I'm adding. Right? And look at what I did. I highlighted because they're all plus. You don't have to worry about the brackets. I just combined all of the x's here. I got 6 of them. I combined all of the values, the constants, that's 300. Then I proceeded to subtract 300 from both sides, or if you want to call it bringing stuff over, the 300 came over, subtracting. You end up with 420. I divide both sides by 6. X ends up being 70 degrees. Okay? So that's how you do one of those. Maybe copy this down. Question 5. Question, is this inscribed? Are we talking inscribed polygons? It's a bit of a trick question. It's not inscribed. Mr. Erickson, what's the difference? What's the difference? You see how these dashed lines go to the center? So this is not inscribed polygons. What does an inscribed polygon look like, Mr. Erickson? That's the ones we did on page 44, let's say, when you have going from corner to corner, you go straight across. That is inscribed on 44 and so forth. There's several examples. So what's up here? What are we talking about? When we go to the center, then we're interested in central angles, okay? So just be mindful of that. I won't trick you, like I won't try to make you think it's a diagonal. They go to the center and then off to the side. So a polygon like that, where do you start when you have one of these? By counting the number of sides. That's where it all starts. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. N is equal to 9. Okay, it's got 9 sides, 9 interior angles, 9 central angles, 9 exterior angles, and so forth. Okay, so we got it. Which one should I start with? I would start with this one. This is an interior angle. And so angle Y can be found by going n minus 2 times 180 divided by 9. Okay, so angle Y is 7 times 180 divided by 9. Angle Y is 140 degrees. So it's not labeled interior angle, but you have to realize that it is an interior angle, so we found 140. So every single corner here is 140, by the way. So you found it. Okay, so you're done there. Next, I'm going to let's find Z. What kind of angle is angle Z or Z? It's an exterior angle. Okay, let's call that exterior. There's two ways I can do this. I can go 360 divided by 9, which is 40. Or I can go 180 minus 140. It's still 40. Okay, so it doesn't matter how you want to approach it, you still get the same answer. Okay. Now, let's hone into these ones here. What is the sum of angles all around the center? It's 360, right? Remember that. X is, I'm going to use a color here. X is not a central angle, folks. That's the key here. X is 2 central angles. Because remember, a central angle only goes along one of the sides, right? That is what a central angle is. You slice one pizza slice, okay? So that's a central angle, and this is a central angle. So let's find a central angle here. I'm going to go angle C is 360 divided by 9, which is 40 degrees, right? That means that this is 40 and this is 40. So angle X is equal to 80, correct? Right? Right. Two times a central angle, which is 2 times 40. So angle X is equal to 80 degrees, all right? What about angle M? How many central angles are part of M? There's 3, right? C, C, C. Okay, so 3 central angles. 3 times central. That's 3 times 40. That's 120 degrees. Please be clear which one is your final answer, okay? What about angle N? There's 1, 2, 3, right? So four central angles for N. So you can go 4 times central. So it's 4 times 40. Angle N is 160 degrees. What would all 3 of these angles add up to? 360, right? Okay. All right, so I'm going to stop there for now. If you want more of this stuff, I will just say 39 all the way to 41. Page 39 to 41. If you want this practice, okay? So solving for central angles, exterior angles, and stuff like that. All right.